Ever wonder who actually builds your apps? Let's unpack the 6 disciplines that keep the software world running. I'm Josh, software exec, former startup founder and consultant, and on this channel, we crack open the secrets of the software industry. Take Spotify. You search for a song and you hit play. It seems simple, right? But there's actually several different disciplines and even departments working together behind the scenes to accomplish that seemingly simple task. Let's break down each discipline from software developer to sysadmin, what they do, how their careers grow, and where they fit into the org chart. And at the end, we'll revisit that Spotify example and show how it all fits together. So let's start with software engineering, the people building the features that you use every day. Software development. Let's start with the basics, software development. Looking at that Spotify example again, everything I'm doing here, from the text box I'm typing in to the search results I'm scrolling through, that was coded by software developers. Developers in all their many forms make up the core of many, many teams. It's probably the most common discipline that you'll come across here in this list. Also colloquially known as devs. Devs are the kind of vanilla ice cream of the industry. Or, maybe if you're in the San Francisco Bay Area, it's the iced soy vanilla latte with an extra shot of espresso of the industry. But yeah, vanilla ice cream. So as far as what they do, devs write code. They're the ones building applications, writing updates and maintaining that app once it gets out into the world. So every time, your software reboots for an update or you get a new version notification, that's the work of a team of developers. Software devs usually work in small teams supported by several other disciplines to help deliver their code. Software development encompasses the designing, building, and maintaining of software products. So if you're starting out in your career and you primarily want to be focused on writing code, this is probably where you'll want to be. Now, software developers themselves are further broken down into additional specializations like front-end engineers who focus on kind of the parts of the application that the user sees, the interface, right? Back-end engineers who work on the hidden systems that support that application. Full stack engineers or even language specific engineers like a Ruby engineer or Python engineer who specialize in writing code in just that language. Generally, you'd start out as a junior engineer, possibly specialized like junior front end or junior full stack, and then move along to a more senior engineering role, staff engineer, principal engineer, each with some additional responsibilities like managing small teams, before transitioning into a leadership role like director. You could also go down an alternate specialization route like architect, senior architect, principal architect, which focuses more on the design of the systems rather than tackling and delivering individual project-based code. And speaking of projects, you'll probably be working really closely, if not on a team, with several project managers of some type, because generally project management is more directly tied into software projects than many of the others on this list. Development as a whole generally all ends up being under the purview of the CTO or Chief Technology Officer. Database engineering. So database engineering is everything data. Scrolling through these results, all of these songs and all that metadata associated with the songs, the artist, the album, runtime, it's all stored in databases with associations between them to make it so that you can hit a button and within milliseconds search through millions of database items and display only the ones that you want to see on your screen. And that's all designed and built by database engineers. I've previously talked in other videos about how all software applications are kind of just wrappers around data, at least more complicated applications than like a calculator. But a database engineer, they're the ones who design that data and they build the systems and structures that store it. And sometimes they even actively manage the data. It's very much about organization and figuring out the most efficient ways to put together what are often very disparate pieces of information in ways that make sense to use. About half of this is the designing and the planning, and the other half is really focused on keeping things running, right? Because data is really important, and you need to have good policies in place for the protection, the storage, and the recovery of the data. And database engineering is the ground floor of all of that. And oftentimes you'd start out in data entry and then work your way into database admin and database architect. Now, database engineering often works in tandem with data scientists, but they are two very distinct and different fields. right? Where database engineering is more about the implementation of the data and the storage. Data science is more focused on what you can get out of that data and how it can be used and modified and combined in different ways to kind of gather insights and do other interesting things. All of this all rolls up to the CTO, but it can also roll up to the Chief Science Officer or CSO, depending upon your organization structure. IT operations. Okay, so maybe I'm cheating a little with the title on this one, but mostly what I'm talking about here is infrastructure engineering. So everything that we've shown up to this point has been on the Spotify website. All that code and all the data, it's all stored and running on computers that are, in this case, what's called a cloud server. It's running somewhere out there in the cloud. And the sysadmins and cloud engineers are the ones who set that up and make it usable. So everything that we've previously talked about, whether it's software or data, it lives on a computer somewhere. And there are pathways set up so that users from outside can kind of get into that computer and see the software that's running on it and use it. So back in the day, we had this elusive creature known as the systems administrator, or sysadmin, who was responsible for keeping all of that running. If the software engineer is the vanilla latte of engineering, sysadmins are the black coffee. They're kind of bitter, definitely an acquired taste, and many days, literally the only thing keeping you running. Because you see, back in the 80s and 90s, and even into the early 2000s, all the computers running your software were what's called on-premises, meaning they were physically either in your company's building or in a special building housing all of your servers. And you'd have sysadmins who would kind of hang out there all day and were in charge of keeping that hardware and those systems running. And the stereotype kind of came about where, they were so specialized that really no one else in the company knew what kind of weird magic they were doing to keep everything online. But what they did know is that if the sysadmin wasn't there, everything was going to go to complete chaos. And so you get this kind of stereotype of a guy in cargo shorts sitting in a room full of servers playing World of Warcraft all day because, God forbid something goes offline. That guy is suddenly the single most important and irreplaceable person in the entire company. A lot of that changes with the move towards the cloud, where now there's less focus on keeping specific computers running and more focus on cloud platforms with distributed hosting. Right now, you're not putting your software on a big black box sitting in an air conditioned room somewhere. You're uploading it to Amazon Web Services or Microsoft Azure or Google Cloud Platform. And now we have a bunch of professions that are solely based around those platforms that have kind of taken over that sysadmin role to some degree. That's not to say it doesn't exist anymore, but it's definitely less common than it used to be. Technically, IT operations encompasses all the internal tech in your company, not just the sysadmins and cloud engineers. It's also network engineering, which is handling how data gets from point A to point B, both inside your company and also routing traffic from outside, or IT support, which is keeping your team's computers and softwares running, and sometimes even security, but I'm going to save that for its own section. Career-wise, this is kind of a cross between software and hardware. You need to know a little bit about both to really excel. And this can be as simple as starting out as a junior systems admin or junior cloud engineer, and then moving through senior titles to chief sysadmin, chief cloud, or even head sysadmin, head cloud engineer, that kind of thing. And you could also use IT help desk as an entry point here into IT operations, and then either move up through internal IT management or transitioning over to networking or server maintenance, or even moving into management from there, right? And all of these disciplines, they often roll up to the CIO or Chief Information Officer. DevOps. So maybe this one's a little less of a full career vertical and more of a specific department, but DevOps spans the gap between software development, or dev, and IT operations, or ops. And that's where that DevOps comes from. It's how software moves from the hands of your developers and into your infrastructure, into your customers' hands. DevOps usually is given ownership over where the code is stored, things like your repositories like Git or Subversion, and release engineering, which is the very, very detailed process of moving newly developed features and applications out to your customers in a seamless way. This used to be the process of distributing a new CD-ROM with software on it and just telling them to uninstall your old version and install what's on the disk, right? But we've come a long way from that. And now there's a lot of complexities to seamlessly releasing software updates in kind of a non-intrusive way. And release engineers are the ones who handle that technical process. Cybersecurity. If you like wearing black or gray hoodies to work, you might have the qualifications to be a cybersecurity analyst. Obviously, that's not true. Cybersecurity can be one of the most complex and stressful fields to work on in all the fields that we work here, outside maybe sysadmins when your servers go down. But it can also be really exciting. Cybersecurity is why I can't just go here and type in a string of malicious code instead of an artist's name. See, the things I put in this text box are sent to the server, and the server has to interpret them. So if I were to type something in that box that the server could interpret in a damaging way, say, for instance, delete all your data, that's what's called an injection. And the reason I can't just type in here and tell the server to do that is because cybersecurity exists. There's a lot of digital threats out there, both from individuals, other companies, or even from other countries, whether it's trying to access systems they shouldn't have access to, steal your data for personal gain or for sale, or even just kind of maliciously damage your systems. And the complexity here, right, is to be really good at defense, you kind of need to be good at everything. But a hacker really needs to be only good at or only better than you at one of those things to completely ruin your day. Cybersecurity is the hacker career. But hacking, and maybe this doesn't need to be said, but it doesn't look like that kind of frantic, high-speed Hollywood hacking that you're used to seeing in the movies. It's a lot more of investigation and research, kind of like digital Sherlock Holmes. You're probably looking at starting out as an SOC analyst of some type and moving through SOC levels as you move up into management. And in general, this is the purview of the Chief Security Officer, or CSO, not to be confused with the other CSO, Chief Science Officer. But again, due to kind of priorities of some companies, this may end up rolling up to the CIO or CTO. Quality assurance engineering. So finally, we have QA engineering, who are kind of the thankless heroes of software. See, everything that your teams make, everything that they change, it needs to be tested. And that's where quality engineering comes in. Anytime the development teams are wrapping up on a project and they package it up and send it off to QA to try to break before the customers have a chance to get in there and break it first. But they're not just hammering at the keyboard trying to break it. QA engineering gets a lot more in depth than that. Primarily building automated tests, not just for code, but for like interfaces too, to mimic the usage and test the software in reproducible ways to find errors. And part of this is called regression testing, which is the process of testing something the same way multiple times over multiple updates to ensure that nothing has changed or broken outside of the expected usage. QA really requires an eye for detail and kind of the ability to think outside the box a little bit at times to find ways to break or exploit software before the end user ends up doing it. And it can be a full career path on its own or often used as a gateway into other disciplines. So career-wise, you'd be starting out as a QA tester and then moving up into either lead QA testing or automations engineering of some type. So let's tie all this together with an example of how all of these disciplines intertwine to create a functioning product. Let's revisit that Spotify example again. I want to search for and play a song. I'm typing the name of the artist into a search form, which is built by a front-end engineer, running a search on an engine built by back-end engineers, which returns an organized list of artists and songs from databases designed and built by database engineers. Clicking on play, and music is streamed across thousands of miles from the server straight to my headphones across networks set up and maintained by network engineers. This whole process ran on servers maintained and created by infrastructure engineers. And I got all the way from search to play without my computer or my phone melting my hands off, thanks to QA engineers. And that's the list. If you found that helpful, please like the video. And if you work in one of these fields, I would love to hear your opinion on my overviews in the comments. And if you'd like to see more videos on software and the tech industry, please follow along with the channel. There'll be more coming soon.